This is lesson 8.1, similar polygons. So similar polygons are polygons with the same shape but a different size. And we talked about similarity when we talked about dilation. So polygons are similar if all the corresponding angles are congruent and all the corresponding sides are proportional. And we talked about proportions being equal ratios. So the ratio of corresponding sides is called the scale factor. So just as we had scale factor of dilation, we're going to have scale factor of similar polygons. And if polygons are similar, then their perimeters are actually also proportional. So the scale factor of ABC to DEF. So they're telling us ABC is the preimage and DEF is the image. So I'm going to pick a pair of corresponding sides. So let's say I picked the 10 and the 15. So if I'm starting here and going here, this is my image. So 15 over 10, which would be 3 over 2. For here, the scale factor of DEF to ABC, so now they're telling me DEF is the preimage and ABC is the image, so I'm going to take 10 over 15, and that's really 2/3. And if I want to know the ratio of perimeter of DEF to ABC, that's going to be the same thing as the scale factor from DEF to ABC, so that's another 2/3. We have a new symbol now for similar, and it's the top of the congruent sign. It's just the squiggle. And when I'm talking about similarity, we're still going to match up angle with angle because remember the corresponding angles are congruent. So for a similarity statement for the triangles above, we could say triangle ABC is similar to, so A had 1 mark, D has 1 mark, B had 2, E has 2, and C had 3, F has 3. Using a similarity statement, we could also work backwards and identify which angles should be congruent and then make a ratio of the corresponding sides. So in our first one, angle J is congruent to angle P. K is in the same spot as M, so angle K is congruent to angle M. And then L is in the last spot, angle L is congruent to angle N. So when I want to do the sides, I'm going to pick JK, matches with PM, but instead of being equal, I'm going to put JK over PM equals. Next two letters, KL over MN. KL over MN. And then JL over PM. JL over PM. And I'm going to do the same thing here. The only difference is I don't have anything called angle R or angle S, so I'm going to have to use a few more letters there when I talk about those. So angle X would have matched with R, so let's call it YRS. Then angle Y would match with angle Y. That's fine, because the Y is the only thing happening there. And then angle Z, which is fine, would be congruent to S here, so we'll call that YSR. And as for my sides, I could go back and use my similarity statement. XY matches with RY. So XY over RY equals YZ over YS equals XZ over RS. So you go ahead and try this one. Pause. When you're ready to see the answer, hit play. All right, so the scale factor, if I picked any pair of corresponding sides, I chose RT, which was 25, and XZ, which was 15. And because XYZ is the image, I put 15 over 25, and I reduced that to 3/5. I also could have used 18 over 30 or 12 over 20. Then I listed all my corresponding congruent angles and my ratio of my corresponding sides. All right, so now we want to solve for x. We want to find the value of x. So one thing I could do is I could use ES over NP and DS over NP. And if I fit and I did the other one, DE is 15 over MN is 18, EF is X, NP and DF 20 over NP is 20. So we only need two fractions to solve. So one of these that doesn't have a variable in it, I don't need. So let's say I focus on these two and I cross multiply. So I'm going to get 18x equals 15 times 30 is 450. And when I divide both sides by 18, I get x is 25. Another way I might sometimes do this is I'm going to look at my shapes and I'll do the same thing I did here. DE matches with LS. So DE, I circle, MN, I circle. EF matches with NPs. EF, side all square, NPs, side all square. Then DF and NP, so I'll put those in triangles. And I know that I want to compare x with something. So if I know x matches 30, then I can pick any other of these two and match with the corresponding. 15 matched with 18 or 20 with 24. And I end up with the same exact proportion that I saw over here. So it's up to you if you want to do the full statement of proportionality or label your sides as what goes together and make your fraction size. All right, so here's another one. I'm going to actually put that one. So I know BC matches with R. So far, I'm going to have x over. I'm going to pick another side here. Let's say I choose AB. AB goes to QR. So 12 over 6. So now I'm going to cross multiply and it's 6x equals 48 and divide by 6, x equals 8. So there's a few for you to try in a row. We'll do one at a time. So try this one, pause it. When you receive the answer, hit play, and then we'll go on to the next try. All right, for try two, I know that x plus x is 32, x 25 plus 1 is 40 using my small x statement. So I did x plus 32 plus 25 over 40. You could have had this and then 4x is 40 over 25. All right, but either way, we get x. The next one for you to try is here. So pause. When you're ready to see the answer, hit play. All right, try three. We would get x is 35 and y is 18. Right, both times I'm solving for a variable, I need to set it equal to an equation that does not have any variables in it. So x over 14 was equal to 40 over 16, and 45 over y was equal to 40 over 16. Again, you can flip those all over as long as you flip everything, and it'll still be good. So now you have try four. Try this one, pause. When you're ready to see the answer, hit play. All right, so on try four, matching up what sides go together, we end up with 36 over x plus 6 equals 32 over x plus 3. When I cross multiply, I have to make sure I distribute. I get x is 21. I'm plugging it back in. xd then was x plus 6, so 21 plus 6 is 27. So now we're going to go back to something we mentioned at the beginning, and that was that the perimeters of similar polygons are also proportional, right? So the scale factor will be equivalent to the ratio of the perimeters. So in this example, we're given KLM is similar to PQR with a scale factor of 5 to 3. So that means this is 5 to 3. So I could choose to keep 5 to 3. I can do 3 to 5 as long as I'm consistent now with which way I'm going in my. So I can find the perimeter of KLM right now. Right? 6 plus 12 is 18. 18 plus 15 is 4. So if I set up a proportion where 3 over 5 equals this perimeter over this perimeter, which is what we don't know, I can now cross multiply this and solve. So we're going to cross multiply 3p equals 165. So p is 55. So you're going to try this one. Triangle TSR, similar to triangle TFE, find the perimeter of triangle TFE. You will have to compare the sides to find the scale factor to do this. So pause and you're going to see the answer. All right, so our perimeter of triangle STR was 116 and 25 corresponded to 40. So I set up 25 over 40 equals the perimeter of TFE over 116. And when I cross multiplied, I got 72.5. So now some word problems. A town plans to build a new swimming pool. An Olympic pool is rectangular with a length of 50 meters and a width of 25 meters. The new pool would be similar in shape to an Olympic pool, but will have a length of 40 meters. Find the perimeters of an Olympic pool and the new pool. If I know the Olympic pool has a a length of 50, and the new one's going to have a length of 40, I can compare 50 to 40 is the perimeter of the one we know to the perimeter of the one we're looking for. If you want to reduce the scale factor before you solve, right, the zeros cancel, so it's really 5 over 4. So now it's easier to multiply, right? 5p equals 4 times 150, that's 600. So the perimeter of our new pool will be 120 meters. All right, so we're able to find that without actually having to find the new values for the new pool. So you're going to try the next one. Same idea. We are creating a new basketball court similar to an NCAA basketball court, which originally has a length of 94 feet and a width of 50 feet. Our new court is going to have a length of 45 feet. Find the perimeters of both. Pause. When you're ready to see the answer, hit play. All right, so the NCAA court has a perimeter of 288 feet. Our new court compared to the old 50 to 45 is 10 to 9. So 10 over 9 equals 288 over P. Cross multiply, we get a perimeter of 259.2. The last problem is now just dealing with some irregularly shaped polygons, all right, pentagons specifically. So I know that the scale factor is 15 to 10 or 3 to 2. And I can find the perimeter of this shape. If I add up all the sides, I get 66. Oh, yeah, 30, 30, oh, 65. All right, so 16, 15, 30, 18, 12, 30. Over, we don't know. So cross multiply, 138. And I can see what I changed this. 13 divided by 3 is 4, 18, 46. So we get a perimeter of 46 meters for gazebo A. And that is section 8.1, similar polygons.